We are just going to go over the major topics of Chapter 1. We started out Chapter 1 just by talking about numbers, a good thing to start off with in math class. And we were talking about real numbers, and we could break those real numbers down into different groups. If you guys remember, our group started with the natural numbers. The natural numbers include what numbers? Think about what you naturally count with. Eddie?
1.
Yeah, 1 and up. 1, 2, 3, and so on. And then our next group were the whole numbers. And the whole numbers are not a whole lot different than the natural numbers, except they include what number? Mike, you want to get something to take notes with? Piece of paper? 0, right. 0, 1, 2, 3, so on. Remember, an easy way to remember this, whole has a 0 in it, and it starts with the number 0. And what was the next set that included the negatives, 0, and the positives? Jake?
Integers.
Very good. And then our next set were the rational numbers. Now the rational numbers can include decimals or fractions. The decimals have to either be terminating, meaning at the end, or repeating. So things like 1/4 or 0.6 repeating or 0.125. Those are all rational numbers. And then irrational numbers are pretty much just the opposite. Irrational numbers are non-terminating, they never end, non-repeating, they never repeat. What's our most famous irrational number? Whitney?
5.
That's right. Or it could just be any kind of prime number that you take the square root of, or any decimal that goes on and on and on and on and doesn't repeat. We also talked about, along with what types of real numbers we have, we talked about their properties. We started with the commutative property. And that said that I could add or multiply numbers, 2 plus 6 plus 1, and I could switch their order around and still have the same answer. So I could do 1 plus 6 plus 2. I switch their orders around, but they stay equal. What property is it where I have my numbers, and I have two sets grouped, and then I change the grouping? So notice the numbers are still in the same order, 2, 6, 1, 2, 6, 1. But I changed the grouping. Kenny? Very good. What's this property? Good, Austin, distributive. And then we had the property that said, hey, I can take a number, like the number 8, add 0, and I get back 8. I can take that number and I can multiply it by 1, and I'll get back 8. What properties are those that say you can either add 1 or multiply by 0, you can either add 0 or multiply by 1, and the number stays the same? Kenny?
The additive identity.
Good. these are the identity properties. These numbers keep their identity. If 0 is added, it keeps its identity. If you're multiplying by 1, the number keeps its identity. Additive is when you're adding. Multiplicative identity is when you're multiplying. As simple as that. What if I have 8 plus negative 8 equals 0? Or 8 times its reciprocal, 1 over 8, equals 1. Those properties had a special name also. Obviously, one's for addition, one's for multiplication. Whitney?
Inverse.
Right. These are the inverse properties. Now, another thing we did when we were talking about our numbers, we talked about patterns. You guys are really good at patterns. I don't think we need to go through them. My words of advice for you on the test tomorrow, read those directions, because if it says describe the pattern in words, you need to describe the pattern in words. If it says say the next figure, then you need to draw or write the next figure. There's usually 2 parts to those. Make sure you do both parts. We also reviewed just evaluating and simplifying. So if we had something like 2x squared plus 8 minus 4x squared plus 1, and we want to simplify. Remember, this is combining like terms. What am I allowed to combine here? Come on, guys, you know this stuff. Jake.
2x squared and 4x squared.
And what do we need to recognize about this 4x squared? What sign's in front of it, Jeremy? Right, so 2x squared minus 4x squared is negative 2x squared. Is there anything else I can combine? Austin? Right. 8 plus 1 is 9. So there is my simplified answer. Something else that we did was evaluating. So we would be given an expression, maybe x squared plus 3x plus 1. And we had to evaluate when x equaled any number, 2. We'll use 2. So what do I do? How do I evaluate when x equals 2? What does that even mean? Bless you. Brooke.
Plug in 2 as x.
Very good. 2 squared plus 3 times 2 plus 1. Order of operations says to do the exponents first. So we have 4 plus 3 times 2 plus 1. Then what? Do I multiply or do I add? Order of operations, multiply or add? Jake?
Multiply.
Right? 4 plus 6 plus 1. That's all addition, so I just go from the left to the right. 4 plus 6 is 10, plus 1 is 11. And there's your answer. Another big part of this chapter was whenever we worked with inequalities. For inequalities, we solved and we graphed. Let's talk about the graphing quickly. I have greater than and less than. Are my circles open or closed? Whitney. right? Greater than or equal to, less than or equal to, open or close circles. Jake?
Closed.
Right. Guys, guess what? You get a point on your test just for being able to do that. Recognizing, oh, this is an open circle, this is a closed circle. Even if you're on the wrong number, you're still going to get a point for knowing the difference there. Now, there was a rule about solving inequalities. What was that big important rule that we had when we were solving inequalities? It had to deal with negatives. Jake?
Is it you have to switch the inequality sign, like flip it around
When you do what?
when you are using negatives?
Using
Dividing.
negatives to do, what'd you say?
Dividing.
Yes, multiplying and dividing by negatives, you have to switch the inequality sign. So, if you multiply or divide by a negative, you have to switch the inequality sign. And let's do an example of that. One minus 2x is less than 5. Solve it. What's the first step? Anybody haven't heard from today? You guys know how to solve. Remember, this is just solving just like a regular equation. Brandon.
Subtract 1 from both sides.
Thank you. So we get negative 2x is less than 4. What should I do next? Jeremy.
Divide -2 on each side.
Good. Now this dividing by negative 2, that is our very important situation when we're solving inequalities. We have to switch the inequality sign. So x is, switch it from less than, x is greater than negative 2. You have to remember that. Multiply or divide in an inequality, and you switch the inequality sign. Let's graph this quickly as a review. Open or close circle?
Open.
Good. Greater than, I need the numbers bigger than negative 2, and that would be the numbers to the right. Anybody remember what we talked about whenever we had two inequalities put together with the words and or? Two inequalities combined with the words and or. What were those called? Starts with a C. And you use this in chemistry when you're putting two chemicals together. Travis? Not combined. When you're combining them, you get a chemical compound in chemistry, and these are called compound inequalities. Two inequalities joined by and or are the compound inequalities. Now let's discuss and versus or inequalities. How many things have to be true with and? You guys just tell me. Alistair? Right? And how about for or? How many things have to be true? One. Can I have two that are true? Yes, you can. So I need at least one to be true. Think about your graphs. Whenever we were graphing these, when you had an and inequality, you would have two graphs overlapping at some point. And then your answer is where both of them are true. So how could I describe where the answer is here? Where would both of these be true? Justin? Yeah, between both of those circles, where the yellow and the blue are both overlapped. So on your test tomorrow, you're going to make sure you want to do the shading right in between there. You can draw the arrows first to give you help, but make sure you have shaded right in between so I know that you're saying this is the only part that's allowed to be the solution. But now when you have or, remember they can go in opposite directions because only one has to be true. We would not need them to overlap because only one has to be true. And there was a special case for both of these. The special case for and was where we did not have anything overlap. So what was the solution? Which is kind of a trick question, right, Kenny? Because it's no solution. If our graph does not overlap, then there's nowhere that both of those are true. That's why it's no solution. Our special case was when our graphs did overlap. Because then you have somewhere everywhere on the graph, you have at least one inequality that is true. What was this special case? What did we call this? Where everything on the graph can be true. All real numbers. Example of both of these. We can have 3x is greater than 9 and four plus 2x is greater than, actually let's make that less than. 4 plus 2x is less than or equal to 18. So we're going to solve both. X is greater than 3 and x is less than or equal to 7. When you graph this, x is greater than 3, open circle, going to the right. X is less than or equal to 7, close circle, going to the left. This is an and inequality. That means both things have to be true. So the only place on this graph that's an answer are where both things are true. That means open circle here, close circle at 7, shade in between. Now for an or inequality. Let's do x plus 4 is less than 6. Or let's make that a negative 6. Just to give you some practice with negatives. X plus 4 is less than negative 6. Or negative 2x is less than or equal to 10. Solve both of these. So we get x is less than negative 10, or, okay, big flashing lights should be going off in your brain right now. Why? Because I divided by a negative in an inequality, so what do I have to do? Very good, switch that sign. Now I can graph both of these. X is greater than or equal to negative 5. Or x is less than negative 10. This is an or statement, so either one of those arrows, any number that's within either one of those arrows would be true. Give me an example of a number that would not be true for this equation. Brandon?
8, negative 8.
Very good. Thing that we talked about in section 1.6 were the absolute values, which you guys have had practice on. There are a few things that you need to remember with absolute value. How many answers do I get?
2, 2.
Right? And I get 2 answers by splitting my equation into 2 parts. One stays the exact same without the absolute value signs, and the other one is set equal to the opposite. But before I can split them into 2, I have to get, Tyler? Hey, give me your pass, please. You have to get the absolute value by itself. Absolute value must be by itself before you solve.
That's actually one of the things I wrote down on here.
Mm-hmm.
If something is in the way of the absolute value being alone, move it first, then make 2 equations, because they're not. They're taking that and then making 2 equations right away.
Yes, yes. You cannot make 2 equations out of this. You will get the wrong answer. That's what they're doing too. That's what the other class did.
Yeah.
So what do I need to do first before I can make this 2 equations? What do I have to do? Have to get the absolute value by itself first. So how can I get that absolute value by itself? Brooke. Thank you. So now I have the absolute value of x plus 4 equals 5. Now this is when you split it into 2. And you have x plus 4 equals 5. And x plus 4 equals what? Brooke? Yes. Now I can solve. X equals 1. And x equals negative 9. 2 answers. Mrs. Riggle said as she was checking your homework, the biggest mistake here was you guys forgot to get the absolute value by itself before you split it into 2. You have to have the absolute value by itself before you split it into 2 equations.